closer here.
I'll just yell for this one, okay? So our next speaker is Egbert Knol, Egbert from Topigs Norsvin in the Netherlands, and did his in the Netherlands, and been doing extensive work in a number of areas. Even though he does work for he's very involved in research, and one of the areas that I was interested to see that he has a really strong background in genetics survival. His actual thesis was on the genetic aspects of piglet survival. So he's going to continue that discussion with us today and give us the point of view from genetics and maybe the genetic gap that we're considering at this point. So Egbert, I'll pass it over to you.
Okay. Is this my microphone?
No.
And now it is. It sounds better. Oh, there is so much to do because I loved the previous speakers and I want to comment on almost everything. This is Topigs Norsvin. It's farmer cooperatives. The left one is Dutch and the other one is... Okay. So I work for a company, Topigs Norsvin, the research center, which is the research part of the international the company, and I'm responsible for research there. So what we do, and it might be not easy to see in the back, there's the pork production chain. It starts with reproduction and feed and feeding, health and behavior, and carcass and meat quality. That's what customers are interested in. And then we have a fifth group of the researchers, that's genetics and genomics. And I come from the lower part. I'm, as Mike said, interested in the quantitative side of stuff. But that engine is being used to try to alter the pork production chain, to try to change reproduction and all the other traits. What I did in this presentation, I combined a number of ideas and slides, and I did my utmost to make it as good as possible. But if you want to try it at home, contact me and then we will work out if you understood it correctly. So the title is Cycle of Life, Genetics of Survival from Early Life to Herd Retention. And then I wondered why Mike invited me. So I'll share some of these ideas with you. It is about the genotype the environment interaction. And you have to realize, and that is what has happened in the previous the presentations, animals influence each other. It is transgenerational. It is the relation between piglets and the sow. It's also the changing the sow and changing the management and the nutrition. So I hope that it fits in your general term. So one of the reasons Mike might have invited me is piglet survival, because this paper came out in June. John Patience was asked by the Journal of Animal Science to collect a number of papers around piglet survival. And he did so in June. He published 6 papers, I think, and this is one of them. And I think the journal liked it, so they commented on the paper a bit. So I'll show you some of the ideas from that paper and extend it a little bit so that it fits this session. The second reason could be that we do quite a bit of work in gilt selection, and not only on the selection side, but also on the management side of it. And this is a presentation a year ago in Europe, and it is by Natalia, and she is a graduate student in Georgia, and she earned a reward. So she was invited to come back this year. So this year she had another presentation on the similar subject, and I'll come back to that. And then I think herd retention fits in that gilt development, and it fits very nicely in the first presentation of this morning. Why do we lose sows? So we had a paper at the AASV, I think, the last year, late breaking news. It was on prolapse. We had the second paper on prolapse. And at this conference, there will be a poster from the Iowa State, because they took our data set, looked at it, and really validated everything and looked at the genetic basis of all of it. So I'm not going to elaborate on that, but because that will come on Monday or Tuesday or something. So I'll have a look at 3 different items, and the first is then the piglet survival. And then I fall back in my quantitative habits. So I have single piglet data, and a piglet is live or dead at birth and live or dead at weaning. It's as easy as that. So it's a binary trait, so there's lots of statistical issues. And that same graduate student helped us to do a very thorough analysis, statistically highly sound, together with the people in Georgia. It's published, so if you're interested. So the model it's a 0 or 1 trait, and there's obvious mean, and there's 30th season, and there's an influence of birth weight, which we saw just before this. And then it's an underscored. It's the genes of the piglet, and it's the genes of the sow nursing, which is not a nurse sow. It's the sow providing the milk. And when I say it, you understand it, and then 2 slides later, you forgot it again. The genes of the piglet has to do with the quality of the piglet, which we call vitality. And the second part, genes of the nurse sow, have to do with mothering ability. So what Kara said, some sows are able to do things with the piglet. They lie down and they provide pheromones or whatever. So this is a simple statistical model, and then we apply it on 9 million piglets every night. There is a system estimating breeding value for vitality and a breeding value for mothering ability. Second is lactation survival, which is pre-weaning survival, similar numbers, some less, because some didn't survive the farrowing process. Number of teats, the Kara alluded to it, we have lots of papers on teats, it's beautiful. We have 5.7 million teat counts, and it's quite heritable, and it's part of the breeding process. Then there is a birth weight, and then it's only 740,000, but it's on a litter level, times 15 or something, so it's a lot of individual data. So this is a paper, genetic parameters of piglet mortality, stillborn, wicked birth, starvation, crushing, and miscellaneous in crossbred pigs. There's a paper from 2013, and it's a Danish paper. And what I want to do here is that our paper is currently, I defended the PhD, the genetics of piglet survival in 2001. And here is actually where I started to work for the pig breeding the company. In that time, the average farm size was 150. And average wean per piglets per sow per year was around 20. And now, here in the US, half of the production, or more than half, is in units of 150,000. The world changed dramatically. It is 1,000 times the numbers. And 40 in Europe is starting to become believable. The Dutch average, really, and that is, with the proper the parameters, is 31, I think. I'll show you some other data after this. 34, 35, I immediately believe it. If a farmer comes to me and says, I'm doing 35, 1,200 sows, I say, oh, okay. I start to disbelieve it at 38 or higher. 40 is getting in the direction. So as a company, we have what we call a balanced breeding goal, and then this red line is the genetic increase in litter size. And you can see that it goes from 0 to 0.75, so it's 0.75 in 5 years, it's 0.15, which fits the earlier mentioned the data. And then the blue line is the number of teats, because we think that every piglet has the right to its own nipple, so it can suckle. And contrary to what we've seen before, and I'll show you different data after this, is that the genetic trend in mortality is clearly the negative. So survival, genetics, we make the animal stronger and we make better mothers. And then this looks so simple, but this is the type of the data we use. There is a humongous number of traits, and these are the observations of a single pure line in a single year. There's a lot of data behind it. So there's congenital defects. There is things like shoulder sores because of the lactation. There is finisher mortality. There is longevity of sows. All of that trying to keep mortality under control. This is national data. And then the top one is the Danish data, and the lower one is Dutch data. So you can see it as Topigs Norsvin data, that's the blue line. Even if a quarter to a third of the production in the Netherlands is different genetics than our genetics. And then in Denmark, it's probably 90% Danish genetics. So in a competitive situation, this is shocking. We should be out of the market 5 years ago or something, or 10 years ago. Look at the difference in litter size. Then if you look at the pre-weaning mortality, then you can see that the genetic trend which I claimed seems to be valid in the market. And in Denmark, they worked, and they are working heavily on survival and stuff like that, and they seem to be successful, but for whatever reason it went up again. So in the end, if you look at finishers per sow per year, it's getting in the same direction. And then we get to the interesting part. Where does it come from? So since we have 9 million individual the piglets, it's so easy to put birth weight against the farrowing survival, and then you get this type. Well, you've seen these before. Eh? So it's clearer in the pre-weaning situation on the right side. And actually these graphs come from that paper from June, Journal of Animal Science, so you can look it up if you want to. And then this needs a bit of thinking, and that's where my question from to Kara came from. So it is total number born, and then farrowing survival if you look at the left graph. And it makes sense that if you increase litter size, that you decrease survival. But I'm puzzled by the left side of it. It's the below 10. So small litter sizes in current sow populations don't have a maximum survival. No, they suffer a bit. And my hypothesis is that there are weaker piglets for whatever reason, because of management, nutrition, or genetics, or whatever. And that's why they survive worse also in utero, and that's why you get the smaller the litter size. But if you estimate a correlation between litter size and farrowing survival, and you use that correlation in your breeding program, then you think that the relation is not as bad as it really is. Because it really is on the right side. And it really is dropping down more and more. So the higher we get, the worse the result becomes. And I'm not sure if you can read the regression coefficients. They're slightly lower than 1, but let's assume that they're 1. So for every extra piglet, you get 1% more mortality. And that fits quite nicely with Kara. She had this little table, and then her result was a bit more. It was 1.3 or something. So we do have a problem that if we increase these the litter sizes, then we get a correlated result in mortality. And if breeding the companies realize what is happening and push the proper buttons, then you can get around with it. So we want more piglets, we want heavier piglets, and we want less variation in birth weight. The consequence is then an increase in litter weight. Yeah. More piglets, heavier piglets, heavier litter weight. And the consequence of that is most probably an increase in mature weight. And then, sorry for this, I'll, on the x-axis it is a litter size, so it is between 10 and 25 here, and it is between 14 and 25 kgs there, and it's utterly linear. The regression coefficient is 0.9. So if phenotypically and genetically we add an extra piglet to the litter weight goes up by 0.9 kilograms. The marginal weight is 0.9. So if you would have an infinite number of piglets, then every piglet would be 900 grams. And that is quite consistent. This is a Danish paper, and they have 450 liters, a litter size of 21, 450 liters, average 21, with 1.2 the kilograms, so that results in 26.3 kilograms of litter weight, which fits extremely well with the data which we have in our database. So there's no doubt we are selecting for more piglets, heavier piglets, and we get more weight out of that uterus, and it has to be sustained by the body. So what we're trying to do, and that's difficult, we're trying to estimate mature weight. So here you have mature weight of boars in a sire line, and then we have some estimation issues, but there's a huge variation. And in a sire line, this is the index, the way we select, and that is going up. And I do not have the data yet, but in the dam line, I anticipate exactly that too, that because of the way we select, we increase litter weight and we increase the mature body weight, which is highly relevant if you just build a barn and you have to produce for the next 30 years. You'd better make sure that they fit. Then we get to damaging behavior in gilts, and that is that presentation at the EAP. My model again. We had a data set of 40,000 gilts from Germany, and they were reared in pens of 10. And then at the moment they're going to be sold, there is somebody checking the animals. Can it be sold, or is it too damaged, or a bad feeder legs, or whatever? So around 5% of the animals is culled because you can't sell it because of the ear or whatever, which costs a lot of money because then it goes away for slaughter weight and instead of as a breeding animal. So we're quite sure that the data is quite nicely correct. So it's sold or not, of course, herd your season type of stuff, and then it's the genes of the gilt, and then it becomes interesting, the genes of the pen mates. So if you have aggressive animals or biters in that pen, they can do a lot of damage. So what we get here is estimates for being a victim. And I never realized that, but if you have a damaged animal, tail bitten or ear bitten or whatever, there is genetic variation in animals that are bitten, which makes life a lot easier because then you have a direct score. And then on purpose, and I said the summation of the pen mates, because you can put a bad animal with a high weight, it still has an influence. So we are able to estimate the genetics of biting. So that is the victim side and there is the aggressor side. This is submitted, so it will come out before too long, I think, using social interaction models for evaluating skin damage in gilts. And that is in the direction of this damaging the behavior. And that links everything together, I hope. There's something called SINS. So the title says a role of genetics in swine inflammation and necrosis syndrome, SINS. And then we look at necrosis at birth. And then the model is animal plus maternal, yeah? A piglet is born, and then there is something wrong, something necrosis, and I'll explain that. And then it's like, yeah, the genes of the piglet and the genes of the mother can cause damage at birth. Hey, that links to that small litter size which I alluded to earlier. So thanks to Natalia, the potential of selecting against the swine inflammation and necrosis syndrome, okay. Skin damage, well, you can imagine that. This necrosis syndrome, when you pick a piglet up at birth, you can see necrosis signs on the ears, on the tail, on the vagina, on the belly, and on the hooves. And it all has to do with blood circulation, capillaries. So if during gestation you're not completely finished, the blood flow doesn't reach the extremities, and then the extremities at birth already somewhat necrotic, and then the pen mates are interested in suckling you or biting you or whatever. So she had, well, an interesting data set, and then the BW is birth weight, weaning weight, the back fat and loin depth, and then the red, the little pens, they're the heritability of that sins. So an individual, the genes of the piglet, when it's born, it's heritable. And there's an estimate, and I'll come back with that estimate a bit later on. Then you can see a number of other items there, and one of them is damage as a guilt. So is it important that you have necrosis at birth and then damage later? So if you look at the correlations, they're all positive, and here and there they're quite positive. So it increases our belief that damage is partly being caused by the victim side, and that victim side comes from early development, even prenatal, and then we get into the cycle of life, and then we get into the environmental issues. So the conclusions from this little part is, since in total, that is the ears, the vaginal, the tail and stuff, it's heritable. The units are correlated, and it's 0.15 to 0.2. So it's a reasonable heritability because it's a 0-1 trait. And there is an influence of the dam. Some dams don't have a uterine environment to produce proper piglets. Selection against the sins will favor birth weight and weaning weight. So increased birth weight will decrease the incidence of this, which fits quite nicely again. We select for more piglets, they get smaller, so they get damaged, and that's why we get into trouble. At the piglet genetic level, since animals are more likely to being bitten after weaning. That's the correlations that I showed you. And then sows, and then I showed you the prolapse, but I didn't want to end with a negative. So, just for Cara, improving maternal care to loose-housed sows. That's a thing in Europe, loose housing, free farrowing, group lactation, and I think it is moving into this continent too, in Canada and the US. So as a genetics company, we need to be ahead of that development. I'm not utterly sure if you can read all of this, but well, the normal problems in during the farrowing. And there's a normal farrowing crate and there's a free farrowing crate. And it is good for sow and piglets if they have more room. It's the nesting behavior, it is the free farrowing, and it is the... But then the problem for me is, what do we do with it? It's a big room, so I don't know if you can see all of this. I showed you the breeding value for mothering ability. So that first left graph, we tested it. So if you make 3 groups of good mothers and not as good mothers, it links 1-to-1 to survival in piglets. So it works. But now we have a new system. So we wonder if our current selection system, which is in curated environment, still works for the new free farrowing environment. We did the small experiments, and it seemed to work out, which is good. But next week, Topigs Norsvin will open a new nucleus barn, and it will have 372 pens free farrowing. So, well, we're a bit worried of the increased mortality, but probably we'll have to suffer 2 years of increased mortality so that we can adapt the animals to the new environment and then be ready for this type of... So this is Chiara Lipori. She started this month a PhD, the project, and she will be heavily involved in this. And we have a number of the research groups helping us out. And that helping out is probably most of you know, but I didn't. If you look at the back leg of that sow, if she has that movement of that back leg, then within an hour she starts to farrow. Yeah, well, probably I didn't. It's a uterine contractions or something which have an involuntary effect on that back leg. So the idea here is you have a camera, and that camera can help you to keep track of sows which are about to farrow. Because normal situation in Europe is that you still crate the sows for 3 days during the farrowing, and then 2 or 3 days after, and then you release them. The ideal situation is completely free, but so we have a camera, and this is one of the options. So a single top, the camera, and this is Swedish data. We collaborated with Sweden. This is a normal Dutch system. Here we have 1 camera for 2 sows, but then piglets can hide between the gates and stuff like that. So we need one camera on a single pen. Then there is Darwin V7, is annotation the software which can help to track the exact shape of the sow, and with that exact shape you can have a look at the posture, if the sow sits or lies down. Or I hope that at some point in time we can also estimate the body weight, because it's a single camera and you have a lot of so you should be able to keep track of the body condition. And then you see the little piglets, and they're too small for this specific the camera. So there's little boxes and they move around. And then it's already easier than I thought, because each of these colors is an individual pig, and it is, I don't know, 2 or 3 minutes of video footage, so you can see the location, and you can see where the sow lies. All the white, that's where the sow lies. So you see differences in movement. So it would be so nice if we could track the individual piglets, because then it links to the colostrum intake. Then you follow a piglet when it's born. You can see when it drinks the first colostrum, and which is last, and stuff like that. So this type of technology is increasing quite rapidly. Then a summary, and that is your question, I think. So what you see here is the weight curve of an animal, and it starts not at 0, but at minus 130 days. So life of an animal doesn't start when it's born at 1.5 kgs or whatever. No, it starts already at the insemination, which is 115 days earlier, and even before that. And that is the, I think Chantal mentioned that if you influence the lysine uptake of sows in this lactation, it has an influence on the next lactation. So that's why we look at the very early. Then there's an inflection point, obvious inflection point, and we're currently looking if that estimate of that inflection point is puberty or related to puberty. because then our selection for growth rate, for development, links very nicely to reproduction, and then we can have much better estimates on when to mate a gilt for the first time, because there will be variation. And now we assume that everybody is the same, and the same weight and same age. And then it goes up to mature weight, and an animal needs 1% of mature weight, 1% of weight for maintenance. So we want to keep them smaller, and that's what Chantal said too. More and more questions, can't we keep sows under control? No, and then the rearing, the part of it. And then you have the body weight change in lactation. Well, they lose weight, and then they influence the quality of the oocytes, and with that, the whole system. So one of the remarks from the first the presentation is that in the large integrated system, you have crews who are responsible for mating, and another crew who is responsible for farrowing. But the first crew might be interested in reducing costs during gestation, and the second is interested in the quality of the piglet. But you have to look at it at a full continuous system, because it keeps influencing each other. What happens during gestation is important for lactation. That's important for the rearing. So how to help each other? Then. Who of you know what PigGen is? PigGen Canada? 1, 2, so it's, let's say, 15% of the audience. PigGen Canada, it's it started with, I think, eight breeding companies, pig breeding companies, which have an office in Canada, who sat together and said, can't we do pre-competitive research in relevant areas where we are not strong enough to do it by ourselves? But by now there are 5 left. And there is a health approach, which is a program of 5 years ago, or 7 years. Yeah, and it produced 60, 70 scientific papers or whatever. The new the research program will embark on survival of the young genetic and genomic approaches, new tooling like the cameras. And Jennifer and Mike, together with Graham Plastow, will shape that program. And you might want to discuss at the end of the day or something if you would like to have a project in this program or whatever. So, selection changes animals, hopefully for the good. I'm not always utterly sure, but okay. Changes in genetics can have the consequences for feeding. Factorial approach. If the animals get heavier, and if there's 26 kilograms of litter weight, we have to re-establish what animals need at what phases. Predicting performance. I think genetic companies are getting stronger and stronger and can predict what an individual animal needs. What you want to do with it in production is maybe a question too. And it might be a wider interest in new tooling like well, I liked the remark about the biomarkers and microbiome and cameras and stuff like that. Thank you for your attention, because the chair is up already for a bit.
All right, let's. I was told I was using the microphone incorrectly, so let's just make sure. That's the feedback from the audiovisual. So. Questions, comments? I think, Egbert did cover a lot of ground. I'll maybe start with one, Egbert. You mentioned the sins, okay, I'm not getting it right. And you talked about selection against the necrotic components, the sins. So if you're going to select against, is that something that you do in the sow, identifying sows that produce piglets with that trait, or not select those as breeding stock, or both?
So what I need is observation population. I need data. These animals are genotyped, and then you can export that knowledge to the rest of your population and select the best animals. This SINS is related to the damage. I'm interested in the damage. So based on that 40,000, we now have implemented a protocol in all our nucleus farms, and we have, in half a year, 90,000 observations. So we'll go from there, and we'll understand what the relation is with SINS without scoring SINS at this moment. So we need to evaluate if the extra recording pays for the... So then your next question is, what should an individual producer do? I would definitely look in your the farrowing crates and pick up a piglet or a number of piglets and check if you can see this. And once you can see this, then discuss with your the farm manager what you can do about it, and if you want to do something about it. You have to
I have 4 kids. I can talk real loud.
Did you ever?
A long time ago.
Well, one of the answers is we know the pedigree of 9 million of those animals. All. We know them all.
All individually.
Yeah, individual. I have 9 million piglets and I know all the boars.
Okay.
Yeah. Then the second is, of course, that there is a contribution of the sire to the offspring and of the dam. And that's a 50-50 thing. And then the mother tends to have an extra influence because she has more opportunities. She has the uterus to kick in. Aside from that, there could be a specific interest from the sire. But then it is the priming imprinting. And every now and then we test that. But so far, we fail to find an influence. So sire is very important for survival of the piglet, for the strength of the genes. And by the way, your analysis of Billy Flowers, we had a student looking at it, and the secret behind it is that from the small litters, the heritability of the whole thing. If you pick the piglets from a large litter, they will give larger litters later on. And if you take that into account, then it explains quite a bit of the results.
I have kids too, so I have a loud voice. One of your early slides, and I might have mistaken this, but it looked to me like it was showing a drastic reduction in pre-weaning mortality.
Yep.
Where's that data from?
From that 9 million observations, because we know the complete the pedigree, and we know that from this generation we picked this group, and then the next group, so we can see how the generations change genetically, and that's what you saw there. And then I showed the phenotypic results, the general Dutch results, which is imperfect, and that shows a similar trend. So all the time we were looking if what we predict genetically, if it is affected in real life, and that should be a one-to-one relation, and it is. So it is our emphasis on that specific trait, and less emphasis on total number born. And that's why we have problems in the market, because other genetics give more piglets. Yeah. in the end, it is about earning money with less and less labor. Labor is the big issue at the moment.
Thanks.
All right, any other questions? If not, thank you for your patience. It's just before lunch now, so lunch will be served just outside. We'll be returning here for